Hi everyone, my name is Evan Smith. I'm a junior and I'm here today with Ginny. She's behind the camera. And today we're going to be talking about polynomials and roots. So yeah, let's get started. First, we're going to talk about the fundamental theorem of algebra, which is basically, these words up here are kind of complicated. It's basically saying that functions have roots, even if they don't show up as like a zero when being factored or on the graph. They can have complex or imaginary roots. So how we find this is I have two functions right here. This one down here can be factored. This one up here cannot be factored. So how we would find the roots to this is we would use the quadratic equation, which is going to be negative b plus or minus the square root of b squared minus 4ac over 2a. Now, make sure you know this because you'll need to know it in your future classes. You probably need to know it in this class. So yeah, make sure you have that down and memorize. Our a value is going to be 1 because it's just 1x squared. Our b value is going to be negative 2 from the negative 2x. And our c value is going to be 2. So now that we know that, we can plug those values into this equation to get the negative 2, which is going to end up being positive, plus or minus the square root of negative 2 squared minus 4 times 1 times 2. And then that's going to be over 2a, which will just be 2. So we're going to simplify this down real quick. And we're going to get 2 plus or minus the square root of 4 minus 8 over 2. Simplify that a little more. We will get 2 plus or minus the square root of negative 4 over 2. Now we see our issue. You can't really get the square root of a negative number and get a regular number. So here we're going to have to use imaginary numbers, which I equals the square root of negative 1. So we're going to be doing 2 plus or minus I times the square root of 4 over 2. And then we're going to simplify that even more to get 2 plus or minus I times 2 over 2. And then lastly, we will get 1 plus or minus I. So that will be our two complex roots to this problem, 1 plus I or 1 minus I. And we know we did it right because we have two roots and it is a cubic function, which means it has a power of 2, meaning it should have two complex roots. And here we would factor that, or if we plug this into just the quadratic formula, we would get normal regular roots. So now we're going to talk about these roots on a graph and how we would find the equation of them, how we would figure out how to sketch them and things like that. So this graph right here is a nice example because it goes ahead and lets us know what the x values are going to be. But when we're writing them, we need to remember we make them opposite because when we're talking about variables that affect x, it's going to be opposite. So it would be x minus 3 times x plus 2, and that would be the just the equation of the graph. But if it was asking it for it to be in polynomial form, we would go ahead and factor that out, and we would get x squared from these two x's. We would get negative 3x from these two. We would get 2x from these, and then we would get negative 6. And we would simplify that down to be x squared minus x minus 6. So that's just a very simple example. But now if we're going down and we are going to see this graph where they aren't defined for us. But as we can see, it goes through negative 4 and it goes through x equals 3. So again, we want to do the opposite because when we're talking about variables that affect the x-axis, it is going to be opposite. So it is going to be x plus 4 and x minus 3. And then again, we can factor that out to get the polynomial equation, which would be x squared plus 4x minus 3x minus 12 to get x squared plus x minus 12. And if you're like unsure when you're taking a test or anything like that, you can always plug an x value in to make sure you have the right answer. So for example, we could plug in 2 here and do 2 plus 4 times 2 minus 3. We would get 6 times negative 1, and that would equal negative 6. And if we check, 2 does equal negative 6. So that's one way to check that your equation or form was right. And then here we're going to try it like from the start. If we're given the equation or the roots, we're going to find out how we're going to put these on the graph and how we're going to predict the end behavior here. So first we can go ahead and start off. We have the zeros here. So I think it's safe to say that we have x minus 2. If we want to figure out what the zero of that would be, remember it's always the opposite. That's a double check. You could set that equal to 0. x minus 2 equals 0, which would get you x equals 2. And then you could double check for x plus 1. X plus 1 equals 0 minus 1. X equals negative 1. So you could go ahead and plot those. But now you're probably thinking, well, how do I know if they're going to come from, up here, if they're going to come up here, or if they're going to be coming from down here? How do I know that? So that's where we have to predict the end behavior. And to predict end behavior, we need to, one, know what if it's an even or odd power, and if it has a negative or positive coefficient. So how we find the power is we find the x's. So here we have two x's that are multiplying, and as we know, when we multiply powers, you just add them. So what's not shown here is this is x to the power of 1. X to the power of 1, meaning it would be x squared, so it is a cubic function, and we do not see a coefficient over here. So if I go down to my chart, we have a even degree, and it's positive, meaning both arrows are going to go up. So we know from that, these are going to be coming or facing up, and then we want to find where it's going to go. So this is where we will find the vertex, which is basically you just want to find the middle point between these, -1 and 2, which would be 0.5, and then you would plug in 0.5 minus 2 times 0.5 plus 1, and you would get -1.5 times 1.5 to get -2.25 to get the vertex. Now sometimes you might, if you're just trying to like sketch and predict the end behavior, you might not have to go all the way and find the vertex, but if you're wanting to be pretty accurate as possible, you'll do that, and then you'll plug in each x value for the equation. Now we have this equation where we have our zeros, which would be -2 and 3, and we have a 2 x's, which would make it x squared, but then we have a negative coefficient, so it would be a negative cubic function. So if we go back down to our little chart over here, let me erase the previous marking, it would be an even degree, but it would be negative, so it would flip, it would be the opposite, it would go downwards. So we know these are going to be going down, and then we would find the vertex. So in between -2 and 3 would be 1/2 again, and when you would plug that in, you would get 1/2 plus 2 times 1/2 minus 3, which would be 2.5 times -2.5, which I believe off the top of my head, it's like 6 point something. Sorry, I don't have a calculator right now, but that would be off the graph. So you would just basically know that this would go up and would connect at that 6 point. Alrighty. And now we're going to talk about graphing multiplicity and how to find multiplicity and what it means. So basically, if you have a single zero, meaning if you had x minus 3, it would just go through 3 like that. Okay, if we're imagining 3 is right there. Now, if we have a multiplicity of 2, meaning it was, we'll use what it has right here, meaning it was just x, say, plus 0 squared, it would bounce right here. This is what you see. This is that bounce. And so if it's a squared root, it's not going to go through, it's going to bounce off. And then if it has a multiplicity of 3, so if we said x plus 1 cubed, that means it would have this little saddle right here. That's what it's called. It's called a saddle. So multiplicity is basically how many times the root happens at that point. So if it happens right here just once, it'll go through. If it happens here twice, it'll basically bounce because it's not able to go through because it's happening twice. And then at the cubic point, if it's hitting the root 3 times, it'll have that saddle. So we're going to practice this right here. We have this 0, which again, it'll be the opposite. It'll be x equals -3, x equals -1, and x equals 3. So we'll go ahead and plot all those points. We have -3, we have -1, and we have 3. So before we get to practicing the multiplicity, we need to find the end behavior. So if we add all of these x's, we have 3 right here, we have 2 right here, and again, not shown, but it's there, we have 1. So all of these together would create a multiplicity of 6. 6 is even, and there's no negative coefficient, so that means we would have a positive even degree. And after this, I'll also show you how to write down what the end behavior would be. So we're going to start from going up, and this -3, x equals -3 up here, as we can see, it has a multiplicity of 3 because it is to the power of 3, meaning it would have that little saddle like that. And then we would be headed towards x equals -1, which has a multiplicity of 2. So we would be going back up to -1, but then we would bounce because of the multiplicity, and then we're going to be headed towards x equals -3, which is just a multiplicity of 1. So we would go, and then sorry, it's a little sloppy, and yeah, so that also checks out with our end behavior because both sides are supposed to be going up, and in this, both sides are going up. Again, this is that little saddle, which represents the root being a multiplicity of 3. Here we have the bounce, which is a multiplicity of 2, and then just going through, which is the multiplicity of 1. So if we wanted to write the end behavior of that, we would say as x approaches negative infinity, meaning it is headed towards the left, because it has the arrow, it's not stopping anytime soon. F of x is approaching infinity. Ignore my infinities, I've never been able to do them right. But that just means it's going to keep going up endlessly. It'll just keep going up without bound. And then for the right side, we'll say as x approaches positive infinity, meaning as it goes to the right, the y values, or f of x, is going to also approach infinity. And now we're going to do a different example where it'll be a odd degree. So as we can go ahead and see, these two powers are going to add up to 5, but then there's also a negative coefficient, which will make it a power of negative 5. It'll be negative x to the power of 5. It'll be a negative odd function. So we'll go ahead and plot the zeros real quick. As we know, it'll be the opposite. So it'll be x equals negative 4, and then x equals negative 2. And then if we go back to our chart, a normal odd degree function, if it was positive, would go up on the right side and down on the left side, because if the x values are negative and they're cubed, that would get a negative answer, but if the x values are positive, it would get positive values if they were cubed. But when we do negative, which would be the opposite, the negative values would then get positive results, and the y values, or the x values on the right side, would then get negative results. So if we go back, we would see that these from the left side would be coming up, approaching infinity, because is it a negative and odd, and then this also has a multiplicity of 3, meaning you would get that saddle. And then we are headed towards negative 2, which has a degree of 2. We would come up and bounce, and then approach negative infinity. So right here, we can check out, this has that saddle, this has the bounce, and it is an odd negative function. So if we check, this is approaching infinity right here, this is approaching infinity, and this is approaching negative infinity. And then if we wanted to write the end behavior for that, we would say as x approaches negative infinity, f of x approaches infinity, and then it would be the opposite when we're approaching the right. So x approaches infinity, f of x approaches negative infinity. That is all for this lesson. We learned how to find the complex root. We learned how to find regular roots through factored form and how to plot them on the graph and then make the equation from it. We also learned how to sketch these functions on the graph and find the vertex for it, and also the end behavior, how to write end behavior, and then multiplicity on a graph and how to graph that. Yeah, thanks for watching, guys.